To those of you out in the virtual world, I am competing against breakfast, and lunch is right behind us as well. The warning about the fire in a presentation isn't wholly without merit, because if you recall the old overhead projectors, I put my watch on an overhead projector once for a presentation and got into my presentation, and then there was smoke starting to come out of the overhead projector. What I didn't realize was my watch band was close enough to the lens of the projector to start smoking. So I literally started at least smoke, if not fire, during one of my presentations long ago. Anyway, we're going to talk a little bit today about Verizon's journey so far through 5G and IoT. Give you some sense of what we've learned so far, some of our insight and perspective, perhaps bust some myths about 5G and address some misconceptions as well. So with that, go to the handy-dandy clicker. Oh, that is all the way at the end. There we go. So let's start with where we're at with cellular right now in enterprises. Cellular, for the most part, is considered to be an adjunct network. It's there for remote workers, for mobile users, for smartphones, for tablets. It's used in some corporate environments as a replacement for office phone system and handsets. So there are some applications for it today. But what type of role is it going to play as we move forward to Industry 4.0? We'll consider first the limitations and challenges we have in both wired and wireline environments and how they're perhaps blocking us from getting to a full realization of the vision of Industry 4.0. With wired networks, you've got the issue of cabling and the cost of cabling. You've got the issues of deployment cycles and some of the long processes that it takes to get wireline services installed. On the wireless side, you've got the issues of complexity between corporate liable devices and bring your own devices, multiple networks to manage. You also have issues around coverage and making sure that there's adequate coverage in the areas where your workers are performing their work. So there's challenges associated with that from a cost, complexity, and coverage standpoint. Risk and security underlines all of that. With any wireless operation, there's concerns, especially among the operational technology community, as they start to have more and more requirement to push data out to business leaders to make decisions on demand forecasting and supply chain information on a real-time basis. Security is really something that the OT world is just beginning to grapple with as they become more and more integrated. I won't say converge, because most OT people would object to that. But those are the types of issues that organizations are coming for when it comes to Industry 4.0 and where wired and wireless have a place. So where does a cellular network fit in all this? Before we get into talking about the value of it, there's a lot of misconceptions and myths about where 5G is today. One of the biggest issues that we see is, why do I need it? If I've already got Wi-Fi 6, why am I going to need something like 5G? Well, there's several valid reasons for it. One is if you consider that mobile networks are adept at mobile assets. The ability to track an asset, to monitor, to collect data from it if it's in motion. It's not something that Wi-Fi does as well, especially if the mobile asset is traveling 60 miles an hour or a high-speed train at 300 miles per hour. So that's one aspect of it. The second is that in a lot of use cases, especially in the manufacturing space, the supply chain space, in the utility space, agriculture space, a lot of the assets are going to be outdoors. And the ability to connect assets with Wi-Fi in those types of situations can be more of a challenge than it can be with cellular. So we're seeing customers adapt to a notion of what they're calling a two-speed network, that they have Wi-Fi for their existing brownfield applications and services, and they have a greenfield approach to emerging technologies and use cases where all manner of new use cases, whether it's IoT, AI, ML, AGVs, AMRs, digital twin, predictive maintenance, all the things we probably all have read enough about in the media, all of those are going to require much more bandwidth. Some will have much lower latency requirements. They all will have heightened security considerations, and it's something that cellular networks tend to handle really well, as those exterior spaces and those mobile assets. When is it going to be available is a question we hear all the time. And there's two ways to look at the question. In terms of, is it going to be available on the public 5G network, and it's being rolled out by all the carriers, and there's a pace, and you're seeing a lot more 5G rollout, and for obvious reasons, in urban areas and cities where there's a density of devices. and it's taking longer to get out to the remote areas where plants and factories, for example, tend to be located. But the beauty of this is that there's another aspect to 5G, specifically private 5G or on-site 5G or even LTE, that can drive an awful lot of business value in those types of situations without the requirement to wait until public 5G services become available. So it's really eye-opening for a lot of our customers to recognize, hey, I can get access to this even in this remote location. Yes, you have to have a link to do a backhaul, but that's land-based. That's not something where new towers have to be built or anything like that. And organizations can have the value of having their own cellular network in-house. What equipment is available? Well, the reality is there's not as many sensors that are 5G enabled. There's not as many sensors that are LTE enabled as there are that are Wi-Fi enabled. That's a certainty. But if you consider the definition of what a device might look like, it doesn't necessarily always have to be a sensor. It could be a camera. It could be an AGV. It could be an AMR. Our definition of the data source in this world is expanding. Next, we hear often we can't afford a cellular plan for every one of our devices. And absolutely the case. Even if it's, as Eric was talking about this morning, even a narrowband IoT connected device at less than $1 a month, if you have thousands and thousands of those devices, it's still a cost. With a private or on-site type of cellular service, you have a base service, but you don't have a unit cost for every device that you add into the mix. So that can make it for an attractive use case. IoT devices aren't as secure as other enterprise devices. And certainly in today's environment, security devices, sensor devices are not totally integrated into most security frameworks. There's still a bit of a one-off aspect to that, and there's a lot of, in the OT space, they want to air gap their technology environment to make sure that the data that's being collected isn't going to be compromised. So that's absolutely the case, and there's a lot of things being done to address that. But if you consider, when was the last time that a cellular network was breached? If you consider the inherent security capabilities in a cellular network and the steps that have already been put in place, the standard that exists with 3GPP, the mutual authentication capabilities, and the encryption. An LTE service is 128 bits of encryption. 5G will be 256 bits of encryption. So there are inherent secure by design capabilities in these types of services that provide that additional value, a layer of risk mitigation. And lastly, we hear frequently, how do I scale this? I've done a use case, and I'm struggling with how do I roll it out at scale? What factors are going to prohibit us from doing that? And the number one obstacle we see when it comes to scale is there's not an adequate ROI that's been developed. It comes off as a science experiment and to prove the concept that it's operational, but it doesn't necessarily measure the impact, or their organizations struggle with translating that into business value that can justify subsequent investments. So that's the landscape we're dealing with. That's some of the types of concerns that are popping up, but hopefully we've been able to bust a few myths along the way as well. So why 5G? Well, if you consider that there's 8 currencies or attributes with 5G that make compelling attributes and value for 5G. We're going to start with reliability. The goal here is that 5G is going to have what is called 5 nines of reliability. And for old telecom folks, that's going to be a familiar term. 99.999% availability translates to about 6 minutes per year of unscheduled downtime. So if 5G is going to deliver that type of availability, then it's going to be very comparable to wired networks and drive the same type of performance and throughput that you might have expected from a wired network as well, along with the device density, along with the mobility characteristics that we talked about. So it's going to change the way organizations look at cellular networks and the role that they can play in digital transformation, to the point where we see some frame-breaking changes, some paradigm shifts for organizations to say, you know what, I never really considered cellular to be primary, but maybe it can be a primary transport vehicle. Maybe it can deliver a whole lot more than what I expected, and I can lessen my reliance on wired services. All done in a zero-trust environment. As we add more and more devices, if you think of how many 5G devices might be connected to the overall network, it's going to create more attack surfaces, more threat vectors. One of the things that we're seeing with 5G right now in its rollout is if you look at all the 5G commercial networks installed worldwide, it's around 220. 70 countries roughly have 5G services available. By the end of this year, there should be somewhere around 750,000 5G devices connected. By 2025, it looks to be about 3.5 billion. So if you look at 2025 and all the IoT studies that show that there should be about 10 billion IoT devices roughly by the year 2025, and 5G is going to have 3.6 billion connections, 5G is going to support an awful lot of those IoT sensors over these next several years. What do you need to know about 5G at this point? Well, I'm going to start first with the comment that LTE supports a surprising amount of use cases, many more than most organizations expect and realize. If a sensor doesn't require latency of 20 milliseconds, or if it doesn't require a 500 meg download, it may be that the sensor or the camera or whatever that data source happens to be, that LTE is going to satisfy it just fine with a lot of existing technologies and a broader ecosystem of sensors available today. So that's one misconception we'd like to address. In LTE, the commitments from at least Verizon is going to be that we're supporting LTE for at least the next 10 years, if not beyond. So it's got a long life cycle still ahead of it. We're still putting improvements in engineering value into it. So it may fit in a way to complement 5G, just as Eric Varney was talking about in his earlier talk earlier today. The other is that enterprise 5G and consumer 5G are not quite the same thing. We actually see a whole lot more upside with how 5G is going to affect enterprises. Yes, it's going to be great for consumers because of the download speeds and whatnot, but for enterprises, it's going to have a similar, if not greater, impact than LTE will. LTE enabled lots of new platform companies to come about because of the enhanced capabilities within LTE, but what we're seeing with 5G is it's going to help a lot of existing enterprises to improve their operational efficiency, to improve quality assurance, and to drive a whole lot of business value in a broad range of use cases without some of the limitations of previous wireless or wired connectivity. It's going to introduce network optionality. There's multiple flavors of 5G, and Eric touched on it earlier today when he mentioned broadband and narrowband. We are going to have high-band services, mid-band services, and low-band services. It's going to enable organizations to kind of mix and match what type of spectrum they need based on their locations, based on their use cases and such. And it may be that 5G will be great for retail environments via the public network, and it may be that private 5G is going to be great for manufacturing environments or agriculture environments because of some of the inherent capabilities that private 5G is going to have for those applications. Not to mention fixed wireless access. Our ability now to deliver comparable broadband speeds in a fixed manner is going to be an attractive option for either backup transport or even primary transport in a lot of locations. I mentioned that security in the 5G space. The only other thing I want to add to that is one of the interesting things about 5G in the security space is that it can encrypt not only the payload, but the user device information and location. So there's additional security that's built in to 5G that organizations are going to like a whole lot as well. And last is that without edge compute, there's going to be a big miss by organizations that are doing 5G. And the reason for this is that as attractive as it is to move applications and services up into the cloud for many use cases, there's also going to be use cases where the work can be done perhaps better by not moving that data up into the cloud. Can we perform that processing nearer to where the work's being done, mitigate our security risk by keeping it on site? So edge compute is going to be very attractive as far as that goes. The other thing that edge compute is going to do is you consider that so many use cases that are emerging that are visual in nature, whether it's dashboards, whether it's different ways to represent information, that all the visual tools that we're going to be using in the future are going to really lean on edge compute to have that high graphics processing being done at the site. So it's another reason that edge compute and 5G have this symbiotic relationship. So what are organizations doing when it comes to IoT and 5G? In so many cases, we're seeing organizations consider a build it and they will come approach. If I get the platform in, if I get the infrastructure in, I'll be ready for whatever the business units throw at me and be able to activate these use cases. The challenge with that is there's no ROI for that because there's no business value coming out of specific use cases, so that often gets bogged down before it really gets started. The next is a one-off approach. one use case, one business case. The challenge with that is that it's really hard to justify an IoT investment, 5G, LTE, or Wi-Fi based with connectivity, unless it has a really strong, compelling business value. And the challenge is there isn't one right now. Even a McKinsey study indicated there's no silver bullet for a single IoT use case that's going to carry the day for the vast majority of organizations. So what it means, if I skip down to the bottom one, is multiple use cases, hopefully relevant and aligned with a combined business value that can justify the infrastructure investment. There's also an approach where it's just incrementalizing as public 5G services become available nearby, just tapping into it and experimenting as it becomes available. So these are the four paths that we're seeing. We're seeing a lot of traction with the multiple use case and single business case approach. So some of the use cases we're seeing the most adoption right now and the most level of interest is in computer condition-based maintenance and predictive maintenance. They're kind of close cousins, if you will. And the ability to gather information, anticipate what is likely to happen with the unit, the system, the component, based on baseline data, and being able to make some forecasts about maintenance and the need to repair in advance before a small problem becomes big. It existed before 5G. We just see some value. If you consider the condition-based maintenance, it's kind of a precursor to digital twins, which is going to be heavily reliant on 5G. So dipping your toe into the condition-based maintenance pool and then diving all the way in with digital twins via 5G is a path we can see. The next is computer vision. We're seeing an awful lot of interest in using cameras, existing cameras or new cameras, as ways to do quality assurance, not just for finished product, but for products in process, for raw materials, for production machinery, and even operators, for operator compliance. We have one customer, for example, that they want to make sure that the operators are performing the prescribed maintenance function every 20 minutes as they're supposed to, because if they don't do it, or they take a shortcut, it's going to introduce risk not only to the operator, but to the machinery and to the finished goods. So they want to make sure people are doing what they're supposed to be doing when they're supposed to be doing it. Cameras are really adept at capturing that type of information in a way that sensors cannot. There's some things that sensors do really well. There's other things that cameras do really well. So we're seeing that complementary approach in a lot of cases these days. And the last one, probably the one with the most amount of easy access, the way to start and get in quickly, is with AR and VR. We're seeing it being used in a variety of different use cases, whether it's remote expert, virtual training, virtual audits, senior agile workforces, the ability to take aging workforce that may be retiring and have them work from home and be a coach on a contract basis, part-time basis. They can be a virtual coach and looking over somebody's shoulder, even though they're retired and working from home. But instead of going from 40 hours a week full-time to 0 hours retirement, they're going from 40 hours a week full-time to 10 hours a week of consulting and coaching for their old company. So a lot of interest in that type of use case to have more flexible workforces. In the international space, there's a lot of interesting things going on. One is that we're seeing that there's more interest in enterprise 5G than there is in the US right now, especially in the mid-band part of the spectrum. We're seeing more government involvement, participation, and incubation to help drive 5G adoption. As I mentioned before, 5G is in over 70 countries right now, and most European countries are really taking a leading position in doing that. We're seeing more adoption over there of eSIMs. Where it's coming here, there's much more investment and involvement with eSIMs over there as well. So we're seeing that the international space, in many respects, is kind of leading in giving the United States some interesting insights as to where it's going to go. We've recently contracted with one of the largest ports in England, part of Associated British Ports, where instead of cabling and wiring 200 Wi-Fi-based access points, they decided it would be more cost-effective to go with an on-site 5G system that will only have 7 radios distributed across this large port. And it'll reduce their risk. It will be far less costly to implement it. Verizon doesn't hold spectrum in the UK. Nevertheless, this organization saw fit with our ability to manage that and to fit all the pieces together, connect everything together, and manage it on their behalf is what sold them on that. And that's a model we're doing more and more on an overseas basis. So what is 5G going to mean to businesses? It's going to mean, from a physical perspective, consider all of the new technologies that are going to be expected to ride on networks coming up. AI, ML, computer vision, AGVs, AMRs, digital twins, condition-based maintenance, computer vision. All of these things are going to consume massive amounts of bandwidth. And it's going to be difficult for existing network infrastructures to keep up with that. Agility is going to be key. Scale is going to be key. And the opportunity to use the flexibility of a cellular network to locate resources and connect to resources no matter where they are is going to be really attractive to organizations. When it comes to the virtual aspect, if you haven't heard of network slicing yet, it's worth getting it on your radar. If you consider that network slicing is going to take a virtual network within a private 5G environment and enable end-to-end connections for certain applications and services, essentially creating logical networks within networks, that will be really attractive to organizations because they can flex based on the application requirements that they have. And lastly, I mentioned edge compute and the importance of the visual tools and methodologies that are coming up. So it's going to be something where edge compute is a critical part of this fit. So often we see IoT projects come off like science experiments, and probably you have too. Even this morning, we were talking with a customer, and the CIO was indicating, yeah, we're really all about innovation, and we're doing this test out in this location to test out IoT. It's not typically integrated into the cloud strategy, into the mobility strategy, into the application modernization strategy. So we're working to get organizations to increase their level of sophistication when it comes to embracing this and not just doing it as science experiments. That's where we keep coming back to use cases, and that's where my group spends a lot of our time, is understanding what use cases can be developed, what business value can be ascribed to it, and how do we act in a way that won't just be an interesting proof of concept, but it'll actually be something that can be commercialized and put into production on a timely basis. So hopefully I've allowed at least 30 seconds for questions if you have any, but I appreciate your time and hope you enjoy the rest of the conference.